the x-axis. So there's my fourth point. It's as magnified as I can get on this piece of graph paper, and that's what I want to do. Alright, now my job is to try to draw the best line I can through this data. So I want to have points of some of the points above and some of below. Try to make an average using your own judgment what that would be. So I think that would, if I drew the line along my ruler, this point would be a little off the line by, say, 2 squares roughly. This one would be down by about 2 squares. This would be a little bit below. This would be a little bit above or right on it. That looks like a pretty good estimate of what the actual linear relationship is for this data. So I draw that line in there. Alright, so that's my best fit line. That's what I'm going to use to find out what the slope of this data is and what the intercept is, so I can find out what the equation of the line is that would be represent this data. So I know that that line is going to look like this, or that equation is going to look like this. Q, the dependent variable, Q, is going to equal some value, the slope, times P, plus the y-intercept, which is usually identified as a B. So in math class, this would have been the y, this would have been m, this is x, and this is b. Y equals mx plus b, the standard form of a linear equation. So now our job is to find out what the slope is, the rise over the run, and what the y-intercept is. Notice that you can't just read this value off the graph for the y-intercept. That is not the y-intercept because this is not 0 on the horizontal x or x-axis. If it's not 0 down here, this is not the y-intercept. We'll have to figure out what that is using algebra. It's very easy. If we know the slope by measuring that from the slope of the line, we'll know this value. We can put in any of our line coordinates for Q and P, any point on the line, and simply solve for B. So that's where we'll get the y-intercept. We don't have to have a graph that goes to 0. If you tried that with this graph, you could see that you would have to extrapolate the line, the graph, way down here someplace to find out where this hit. And you'd have to have a great big tall scale on the y-axis, or q-axis in this example, to find out where that hit 0. So we don't do it that way, we just use algebra. Okay, so you need to find the slope. Well, you need to find 2 points on the line. 2 points on the line, not the data. The data obviously is off the line, so we're trying to find the slope of this line. I want to make the points as far apart as possible to give myself the smallest reading errors of reading the graph. I'm going to have to interpret where my line is hitting the graph. I would make it easy on myself, perhaps. Notice that the line crosses right there. So that would be a great point to pick because I can easily identify what the coordinates of that point are. Look down here, look further down and see if there's anything that would be easy to use down here. Again, you don't have to go to the total extremes, but you want to get a reasonably large triangle out of this. So how about this point? That looks like a good one because again it crosses one of the graph grids. So here's the triangle that I'm going to be using to identify the slope of this line. It's not the largest triangle I could find, but it's the easiest to identify the coordinates for those points. So that point has a P coordinate of 0.055, because remember this was 0.051 here. So this is 0.055, no, that's wrong, 0.0505. That's what this would be. You have to, it's halfway between 0.050 and 0.051. So it would be 0.0505. And its vertical axis value, go across here, would be at 70.75. Remember that this was 71 up here. So this would be comma 70.75. So that's the coordinates of 1. My second point that I've decided on has a vertical axis value of 73.75. And if I look down, it's at 0.045. All right, so it was right on that line. So those are the P and Q coordinate values that I'm going to use to figure out what the slope is. Once I know the slope, I'll be able to algebraically solve for the y-intercept, B. All right, so how do you figure the slope? Slope equals m equals the difference in the y values over the difference in the x values. The rise over the run.